So thank you again and welcome to our virtual forum for residents of Guilford and Madison, and really for anyone interested in how long-term sea level rise is affecting coastal communities. This webinar is brought to you by a great group of folks at Audubon, Connecticut, the Connecticut Department of Energy and Environmental Protection, the Connecticut Audubon Society, and Menunkatuck Audubon Society. And today's presenter is Dave Kozak from DEP. So today's forum is meant to help you understand how you as a local landowner can help address the issue of long-term sea level rise, which is impacting our local communities. As an important marsh stakeholder, potentially, we hope you will leave today's forum with next steps and a plan to work with us to sustain the marsh into the future. We are recording this forum so you can access it after the fact. And and also, sorry, if you don't want to be seen on camera at any point, that's fine. Just keep your video off. You can still ask questions in the chat box, or you can unmute yourself to ask questions when the time arises. So we will also have time at the end for discussion. We hope you'll stick with us, and we look forward to speaking to you, learning more about your interests and where you live. And I'll pass it on to David to begin the presentation. Thanks.
Good evening, all. Thanks for sharing your Wednesday evening with me and my colleagues from the Audubons. I have worked with the Connecticut Department of Energy and Environmental Protection's Coastal Management Program for 29 years, principally assisting coastal municipalities review development proposals, acquire land for coastal land conservation, and managing flood hazards, as well as taking a look at how sea level rise may be affecting our saltwater and brackish water marshes. Today, we're going to focus on the East River Marsh in Guilford and Madison. Last time I worked in the communities, we were able to assist the town in acquiring the East River Preserve at the very head of the marsh. The marsh is over 900 acres, and it's one of the largest high marsh dominated coastal marsh systems in southern New England. It's been around for between 3,000 and 5,000 years, and over the last century or so, it's pretty much been able to keep up with sea level rise. These marshes outlined here, at the head of the East River Marsh, only can survive at a delicate balance between being flooded frequently enough to support the types of plants that define a marsh and dry enough in order to be able to exist. They're not underwater plants. They are intertidal plants. It means they're subject to the ebb and flood of the tide. There's a drying period and a wetting period. Sea level rise is one of the more recently recognized threats to our marshes. There are others, including filling and other kind of disturbances, which we've addressed through legislation and regulatory programs. Invasive species have invaded our marshes. We've changed the hydrology of our marshes, including modifying them with mosquito ditches, which has changed the hydrology and the ecology of the marsh. What we're going to focus on today, though, is the effect of this more recently recognized threat of changing, more accurately, increasing levels of sea level rise and how it's going to affect the marsh. If the rate of sea level rise increases beyond the rate that the surface of the marsh can increase to keep up with that increase in sea level rise, it'll drown. It'll also respond by trying to move upland or inland to try to sustain itself. So those are two ways we can try to think about the challenge that we're going to talk about a little bit more. There are threats within the existing footprint that may or may not happen depending upon whether that elevation of the marsh can keep up with increasing rates of water levels in Long Island Sound, and how we manage the upland surrounding the upland edges of the marsh to allow the marsh to migrate inland to survive. Now, to do this, we need the cooperation of the landowners who own these areas at the upland edge of the marsh. We're calling those areas where the marsh moves out of its existing footprint onto the currently dry upland that becomes increasingly wet with sea level rise. marsh migration areas. And we're going to need the cooperation of the owners of these areas to ensure that they remain undeveloped for the marsh to expand its existing footprint, where marsh grasses can continue to survive on what is now dry upland, but will become wetter and able to accommodate marsh vegetation in the future. What we don't want to happen is that land that is identified as capable of supporting marsh in the future to change to a land cover type such as housing or any kind of pavement that would preclude the marsh from being able to move into those upland areas where it would otherwise be suitable for moving upland and inland. Let's go over a little bit more detail what we're going to talk about. We're going to talk about why these marshes are important, where they are, and what they are. We're going to talk a little bit about what the East River Marsh looked like in the past, about 100 years ago or so, some pretty cool historic mapping that we have and aerial imagery, and what they look like now, what the marsh looks like now. How coastal marshes in general respond to sea level rise. What's the mechanism? What are the ecological mechanisms that marshes use to try to adapt to sea level rise? And then we're going to look more particularly at the East River Marsh and its projected response to sea level rise using a computer mapping program called Sea Level Affecting Marshes Model, or SLAM, that's been used throughout the country in just about every coastal state in the country to try to anticipate how marshes will change. And then lastly, we'll talk about what will be the landowner response to this change. How will you as coastal landowners along the edges of the marsh, how will you be affected by increases in sea level rise? And how will you be affected by your changing backyard, which can become flooded more frequently and perhaps become marsh? First of all, always good to start with a definition. What are these coastal marshes? So these coastal marshes are transition areas between low energy water bodies, such as this river in the background. We can consider that, for example, the East River. Not subject to lots of wind and waves or strong currents. It's a low energy coastal environment. And uplands, here defined by this tree line. So in between these low energy coastal water bodies is this transition, and the upland is this transition zone where coastal waters come and flood up over the banks of the river and flood the marsh and then recede, and they leave salts in the soil. And it's this process of wetting and drying and the deposition of salts in the soil that form a salt marsh. Generally defined as an area of low marsh with these grasses here called the smooth cordwater grass right along the edges of the rivers and the tidal creeks. Way up on the other side is the upland area or the marsh border, usually defined by 5 or 6 different types of shrubs. But in the middle is this large open plain called the high marsh, which is infrequently flooded. We'll talk about this a little bit more using a graphic that was prepared by Patrick Lynch in a great book called A Field Guide to Long Island Sound. Let's take a look at this blue dash line here closest to the water. This marks the upland extent of the low marsh, or the frequently flooded marsh that's flooded twice a day during the high tides. The water comes up out of embayments or up out of rivers and pretty much comes to this mark called the mean high water mark. And it supports a low variety of plants, principally the saltwater cordgrass. As we move upland in the landscape, up towards the upland area, we have that high salt marsh plain, the largest part of the marsh. And within this marsh, there are small depressions, such as this. Lower elevations of the high marsh where salts collect and the soil is such that there's very sparse vegetation in these areas. There are also pools that have constant standing water. Also in this high marsh are creeks which pass through the marsh. And perhaps you've seen this if you took a look at the very nice video that was produced for this program that was included in the invitation. These marsh creeks run throughout the high marsh, and they are bordered, again, noted by this dashed blue line, by these tall grasses called the saltwater cordgrass. A few grasses on the high marsh dominate, such as the black grass, the salt meadow cordgrass, a few other grasses. And then the last part of the salt marsh or the coastal marsh is this marsh border. And this is also a narrow area, much like the low marsh. And this narrow band includes a variety of plants such as switchgrass, beach plum, bayberry, the groundsel tree, the high tide bush or marsh elder. And these are often woody plants, interspersed perhaps sometimes with cedar trees. And then the upland area of the forest in this picture, sometimes bordered also by upland lawn. These creeks are important because they support a variety of life that many of us are familiar with. So what we want to do is try to make sure that only those uses that are consistent with sustaining these plant vegetations and these animals that use the waters of the marsh are not harmed. And we do part of that protection by regulating these coastal marsh areas, but using the Connecticut Tidal Wetlands Act through the Connecticut Department of Energy and Environmental Protection's coastal permit programs. Now, where local landowners come into play as far as their marsh management decisions and the effect on the fate of the marshes in the future with sea level rise is this upland area comprising the upper part of the marsh border, this shrubby area, and the area here of woodlands, and sometimes it's open fields or lawns, where marsh currently doesn't exist, but with increases in the rate of sea level rise, will become wetter and wetter and transition to marsh. But it will only be able to transition to marsh within these marsh migration areas if that land is kept in a condition that can accommodate that type of change in plant community. It won't happen if there are buildings on it or blacktop, and that's what the target is. I want to talk to you more about today. So how are we going to do this? Well, we've used these programs, for example, the sea level affecting marshes model, to try to identify those marsh migration areas with the greatest conservation value. Where are the larger ones? Where are those properties that are most likely to support marsh in the future? We've got to understand what the target is. We also need to understand what the landowners' plans are for their properties and what their concerns are about managing their marsh front, managing their property that could increasingly be flooded, certainly during coastal storms and during regular tidal events with sea level rise. And then we need to work with those landowners to develop marsh management or conservation strategies. How can we help you manage your land so that you can enjoy your marshfront property without harming it? And can we come to some kind of agreement to ensure that your land will remain in a state that can accommodate the future migration of these marshes in the future, even after you no longer own it? These marshes principally occur within embayments, or embayments are these little recesses or indentation in the shoreline. For example, here's New Haven Harbor, that's an embayment. The arrow here points to Guilford Harbor. The mouth of the Connecticut River here, Niantic Bay here, Thames River here. These embayments are lower energy environments where our major tidal marshes occur because they're low energy. We also have very little sediment in our waters in Long Island Sound, which is another important ingredient to creating marshes. Our coastline is a bedrock dominated system such that there isn't a lot of new sediment being generated by wind and wave action that hits the coast because it is such a hard shoreline. So the sediment that's important for feeding these marshes so they can keep up with sea level rise, there's not a lot of new supply of that sediment being delivered. The sediment generally washes in and out along the shorelines. These marshes exist within these valleys defined by ridges shown here in the dashed red line. And usually within these valleys, we have glacial meltwater deltas. It's on top of those sand and gravel deposits that were placed here during these glacial meltwater deposits on which most of our larger marshes exist, shown here in yellow. Let's take a look at that from an aerial perspective. Same place. Here are those ridge lines. And between those ridge lines are these valleys where marshes like the East River Marsh reside. So as you start to move upland and inland in these valleys, the slopes of the adjacent lands often increase, making it difficult for the marshes to move upland because of those steep slopes. So that's something that we need to concern ourselves with as well, because it's going to be more difficult for marshes to migrate when you get further up these valleys and the landscape starts to be a steeper slope along the edges of the marsh. So let's take a little tour of what the marsh looks like. We'll do that through a series of photographs. Let's start way down here at Guilford Marina at the harbor, kind of the mouth of this valley. Here we have a broad plain occupied by this high marsh with some creeks. This is Sluice Creek cutting through. Here's the East River. Here's Grass Island, the boat launch, and you have these broad plains often at the mouth of these valleys where these marshes sit. And then as you move inland, for example, here north of the Amtrak and south of Route 1, we start to see a change in the marsh landscape. You can now see the constriction of the valley. Here's the east side of the valley, and here's the west side of the valley with more ridgeline. And you've got a much narrower plain within your or marsh platform here. And you're also starting to see changes in the vegetation as a result of some of the crossings of these valleys used by railroads and roads and tide gates, such as the tide gate down at the Guilford Marina, which is restricting the flushing of this marsh, changing the type of vegetation from the more natural vegetation we'd expect to see in a marsh to more invasive plants such as this common reed or Phragmites australis. We'll continue to go up all the way up to the head of the East River at the East River Preserve. And here again, you'll see the steep banks of the valley and fewer opportunities for the marsh to move inland and upland. So we'll take another look at this marsh. You can see up here the general direction of the camera shown in this red cone. So the direction of this red cone here is going to show you where this picture is taken. It was taken from a drone, and we're going to do a scanning of the marsh by going along with the camera. Okay, so here we see the Amtrak rail line, the East River. Here we start to see some of the complexity of the marsh landscape. The marsh does not exist in isolation. It is surrounded often by roads, by homes. There are islands in the marsh, such as here, a little bit higher elevation. These areas would likely be marsh migration areas as well. They're also currently important for a variety of birds that use the marsh. Here is Garnet Road in Madison. Many of you know it. Those who do live there know that it floods from time to time. And this is another issue that we're going to have to deal with, because as we manage these roadways, perhaps elevate them to make them more resilient or resistant to flooding, we're going to be affecting our marshes. There are often culverts that go under these roads. For example, you can see here a creek. The creek goes under the road, and there's a culvert here that joins it to the other part of the marsh. And as we reconstruct these roads, we'll have opportunities to change the flushing of these areas that are inland of the road, and managing such that bringing more salt water into these areas to restore some of these areas of the marsh that have been harmed when these roads were constructed. So we'll continue to zoom around. We're looking north now, then out towards the Sound. And again, a nice picture of the complexity of these marshes surrounded by the Sound, homes along the beach fronts, a variety of upland areas within the marsh, showing you a little bit about the complexity of the marsh. Okay, so why should we care about these marshes? What do they do for us? And what do they do for some of the plants and animals that depend upon them? Here's a description of the food web for Long Island Sound. We all recognize many of our iconic animals of the Sound, such as the seals, striped bass and bluefish and various types of waterfowl and other birds that we're very familiar with in the Sound. But here at the base of this food web is what we're calling the detritus. It's organic matter that has been shredded and decomposed into small pieces by a variety of decomposers, various types of zooplankton, for example, and others that are providing the basis of the food web. And it's these coastal marsh grasses, various plants within the marsh, break down into these little pieces of detritus that support all these higher levels of energy and animals that rely on this soupy mix of detritus that exported out of the marsh in the creeks and the rivers out into the Sound, so that we can enjoy a variety of things that we all know a little bit more about, perhaps, such as the salt marsh sparrow, which nests in the marsh, glossy ibis that use it for loafing and for feeding, shellfish that depend upon clean water that's provided by the marsh. The marsh is a great filter of pollutants. And because of these services, what we call ecological services that the marsh provides, we get to enjoy the Sound in a variety of ways, whether it's through boating, fishing, kayaking, and these are all reasons why we want to make sure that we have a healthy marsh system. There are other important ecosystem services that are provided by the marsh as well, such as flood and erosion control. These marshes are the first line of defense. When a storm comes in, the wave energy is absorbed first by these marshes before it hits uplands that are often built upon that would be threatened by these storms if they didn't have these first line of defense. And it only takes as little as 30 to 40 feet of marsh along a coast to significantly reduce the wave energy that's delivered to the coast. These marshes also are like big sponges that absorb coastal waters during flooding and then slowly release them after the storm recedes. And without that type of flooding attenuation or mitigation, we would have more flooding in our coastal communities. Again, they're kind of like big sponges in your backyards that are soaking up these flood waters and slowly releasing them. But in some areas, we have not wisely chose how to build along our marshes. And we are seeing flooding out of these marshes into areas of a community that perhaps would have been better off if they were less densely developed or developed in a way that would allow the marsh to expand. For example, here's a road along not the East River Marsh, but the Wheeler Marsh in Milford, where road flooding is more frequently occurring, and the municipality is coming to DEP to elevate their roads in response to this kind of flooding. But if these marshes didn't exist, or they disappear and they can't sustain themselves over the long term, this type of flooding will likely increase. So another important, but sometimes not mentioned, value of these marshes are they're incredibly important aesthetically to our community and help define the aesthetics of our community. And I'd kind of be interested here at this point to hearing from you. Which of these ecosystem services, perhaps others I didn't mention, are important to you? Would you care to talk about why you decided to give up your evening tonight and talk about the East River Marsh and what's your relationship to it? How do you benefit from some of these ecosystem services? Anyone want to chime in? Can we Sharon, unmute those who might want to raise their hand?
Yep. If folks have a question, you can unmute yourself, or I can unmute you at this point, or you can type it into the chat box. Or sorry, not a question, but an answer to David's question.
Yeah, can you hear me?
Yes.
I know I'm kind of dark here, but I think the thing that attracted me the most to this talk was not the science, but the undeniable beauty of the marshes. We're in Indian Cove and lucky enough to be surrounded by marsh, and reminded every day that if it were not for those marshes on the coast, that we'd be a suburb we'd have houses all around us. And the marshes are kind of a breathing space for our community, as well as a wonderful site where the colors change with every new season.
They really are beautiful. Like you say, every season, the marsh grasses are slightly different colors, slightly different in early summer than late summer, fall and spring. So yes, I think it's something we don't often mention. We talk about sometimes the harder, quote unquote, the more definable marsh ecosystem services such as flood control and erosion control. But just the beauty of these marshes, I think, are incredibly important to the character of coastal communities. Does anyone else want to chime in, or should we continue?
We had a question in the chat from Julie. Are marshes much of a carbon sink?
Yes, they are a carbon sink, and our University of Connecticut is trying to evaluate how that carbon sink and how they process other nutrients, especially nitrogen, which excessive loads of nitrogen to Long Island Sound and some of the embayments can seriously affect, in a negative way, water quality. And so the University of Connecticut biologists are studying how these marshes absorb carbon, nitrogen, and other nutrients, and how that ecosystem service change of nutrient, what they call nutrient sequestration or absorption, how that will change with changes in the marsh. If the marsh changes to a different type of vegetation, how will that carbon and nitrogen attenuation storage, how will that change? So it's going to be interesting to see some of the results of this. But yes, they do capture carbon and other nutrients. And with that, I'm going to continue on. We can come back, but I just want to get some thoughts as to why people bothered to show up tonight and why the East River Marsh was important to you. So let's take a look at the river, at the marsh, what it looked like in the past, what it looks like now. Look at these guys. This is the 1930s era Work Progress Administration ditch diggers who throughout the coast of Connecticut and other parts of southern New England, especially during the 30s, were digging digging ditches in salt marshes for mosquito control. Although these guys were preceded by at least 100 years by colonial farmers who farmed these marshes for salt hay. So as early as the 1700s and early 1800s, we know that farmers were trying to manage the hydrology of these marshes to dry them out so that they could more readily harvest salt hay. But it was really in the 1930s when the salt marsh ditching really took off in earnest. And there's estimates that between 80 and 90% of all Connecticut's coastal marshes have these ditches in them. So here's what the marsh looked like in 1880. So in the upper right-hand corner, giving you a little bit of context. Now here's where the larger picture is. Amtrak Railway, South Union Street. Here's Leach School over here. Route 146 Boston Road intersecting with Route 1. And this is what the landscape looked like in the 1880s. This was based upon the National Coast and Geodetic Survey, which did very detailed mapping as early as the mid-1800s through the mid-1900s. And we're lucky enough to be able to have these maps and photographs. I'll show you a little bit later what the marsh looked like and how it's changed. The only real development we see here, here's some structures along the Boston Road 146, which is just a few here. The rest shown in this green outline is the marsh boundary. So everything in green is marsh. This stippled area is either cultivated land or forest. But again, a pretty naturalistic landscape in the 1880s. One thing that's missing from here that you will see now as we go into the 1930s at the same place. Again, here's a little bit of context. South Union Street, here's Saw Pit Road, if you know that. Soundview, here's the Amtrak rail line, Route 1, 146. Here these mosquito ditches stop popping up in kind of this grid-like pattern. And that was a significant change in the early 1900s to Connecticut's salt marshes. And we're still trying to figure out how to manage the effects of those salt marsh ditches. And as early as this period, we saw some filling of the marsh. These red circles show areas that were formerly marsh, This was the marsh boundary again that I showed you from the 1880s. And now this has disappeared. The area over here has also disappeared from marsh to non-marsh. Now let's zoom ahead to current day. Again, a little bit of perspective as to where we are. This larger photograph, and the blue stipple shows the existing outline of the East River Marsh. Again, with some context to show you where you are. And now if we if we were to compare the outline of the marsh for this part of the East River Marsh between Amtrak and Route 1 from the 1880s, all of these areas shown in circles are areas that were marsh in the 1880s, but no longer marsh. So there has been significant filling and dredging and draining and construction of all kinds of infrastructure throughout the marscape that's significantly affecting the health of the marsh. And it's been demonstrated that those marshes that have been beat up in this kind of way are likely going to be less resilient to sea level rise. And we'll talk about that a little bit more in the future. So how do marshes in general respond to sea level rise? Think of it this way. These marshes are kind of in a race with Long Island Sound. Long Island Sound wants to drown them out. And Long Island's water levels in Long Island Sound have been rising for centuries. And they are rising and trying to overtake the marsh and turn it into open water. The marsh is responding in a couple of ways to prevent that from happening. It's trapping more sediment as the water comes and floods onto the marsh during the high tides. It traps sediment and starts to build the elevation of the marsh. Some of the plant growth then dies. The detritus of that plant material starts to build the elevation of the marsh. So all kinds of biogeochemical reactions going on in the soils that are also changing the elevation of the marsh. So it's this competition between the marsh trying to rise to meet the rising sea level. And as long as these two are kind of in equilibrium, and they have been for the past century or so that we know of, in this area between 2 and 4 millimeters a year of sea level rise is pretty much matched in a natural marsh. They have not been affected by man. That the accretion of the sediments and the organic matter and the building up of the elevation based upon what's going on subsurface, it's been able to match that sea level rise of between 2 and 4 millimeters a year. But with increasing rates of sea level rise, the prediction is that the marsh may not be able to keep up with the increased rates of sea level rise. So that's one way that a marsh tries to respond to increasing water levels in Long Island Sound, building its marsh elevation. Another way is it tries to move inland and upland. So for example, here is sea level in the past and marshes growing in this intertidal area that are regularly flooded by the ebb and flood and the tide. Now with current sea level, this marsh is gone. This is all now marsh peat down here where the former marsh existed. But this is a nice gentle slope and it's undeveloped and it has the types of soils that are well suited for marsh to move inland and upland, and that's what's happening. And that's what we expect to continue to happen in the future as sea level rise continues in those areas where there's enough sediment in the water to build up this elevation. We have a nice gentle slope and we don't have development blocking the marsh. As long as this can happen, this is a second way that marshes can try to keep up with sea level rise, moving laterally and inland to try to expand their footprint. But, and there's a big but, in parts of the country, especially in New England, where we have steep terrain along parts of our marshes, the marsh cannot move up the slope. We don't see marshes on hillsides, right? We see them on broad plains. So we have to have that gentle slope along the edges of the existing marsh. If we have an abrupt slope such as this, the marsh drowns. Now, in some areas, we have that nice gentle slope upland of the existing upland boundary of the marsh, but the marsh can't move inland because it's being blocked by some type of structure usually. And it results in a net marsh loss. And this is what we were concerned about. We want to make sure that if there are these areas that are available to accommodate the upland migration of the marsh, this does not happen if we value our marshes. And there are barriers to salt marsh migration. People want to try to protect their upland, and they do that in a variety of fashions. So here's some pools of water, likely from an extreme high tide or perhaps a storm. And here's one type of response to that inland or upland movement of marsh is to try to fortify it. And if this were to occur, we're not going to be able to allow this marsh to naturally move inland or upland like it wants to. So I'm going to again stop here for a second. Now I've talked a little bit about changes over the marsh from the 1830s up to current day. How about you, or even maybe more recently, for those of you who are lucky to live along the marsh, maybe for 10, 20, 30 years or more, might be on the call. Have you observed any changes in the marsh in your backyard or perhaps in other parts of town that you regularly visited with marshes? I'm curious.
I live on Long Cove, which is just adjacent to Indian Cove.
Okay.
And we've lived here for 30 years. And we've watched the marsh change from what looked like a wheat field to what is now an absolutely beautiful marsh with the open areas and everything, excuse me, that you've been describing. Mm-hmm. If you go along Route 146 near the entrance to Westwoods there in Sam Hill, mm-hmm. you can see the very top of Long Cove, which is the very degraded section of the marsh. If you ever want to see kind of a comparison, what a healthy marsh would look like versus what a very degraded marsh looks like, there's a little patch of land across from the Sam Hill entrance that is part of Long Cove, but is cut off by Route 146. Mm-hmm.
I have heard of similar stories throughout the coast, especially where roadways cross these marshes. There's speculation that these narrowings in the, when causeways or roads were built over some of these marshes, they may have restricted the amount of sediment that can be delivered into the marsh, placed on the marsh surface, and that's changing the elevation of the marsh surface relative to the water levels. Go ahead. Yeah, go ahead.
I was going to say what happened with Long Cove was that there was an active state of Connecticut effort back in 1986 to restore the marsh. And the way in which they did it was they opened a culvert that had only been draining the marsh for years and years, instead of allowing the water to wash in with each tidal flush. And right. So with that culvert being opened, that allowed the marsh to ultimately change.
And we in the agency are still working on those types of modifications to the hydrology of the marsh to make sure that we can deliver the water and the sediment into the marsh, and just as importantly, drain the marsh at low tide. If those culverts are raised too high and they can't drain the water well enough out of the marsh, the standing water on the marsh continues to degrade the marsh. Anyone else want to share any insights in what they've seen in marshes they might live next to over the past couple decades? All right, well, thanks for sharing that. So
one thing I've noticed is that there's a lot of dead zones at the edges of marshes. I think some of that may be a temporary effect because of the metonic cycles, because over the past decade or so, there's been higher tidal cycles because of the lunar configurations. But I've been noticing a lot of marsh dieback at the edges of marshes all around Connecticut, and I'm hoping it has to do with the metonic cycles. And the other thing is I'm noticing that the salt marsh sparrow is much harder to find, even in places where marshes appear healthy, especially in the East River Marsh.
Interesting. Well, to try to project how these marshes might respond to increasing rates of sea level, we have applied the sea level affecting marshes model, or SLAM model, to Connecticut's coast for all of our marshes. And we have now focused on the East River Marsh, and I want to show you what some of the results of that modeling are for this marsh. But first, we need to understand what some of the what goes into this model. So the model actually used 5 different sea level rise scenarios, 2 of which I'm showing you here. At the bottom of the graphic, this dashed line is the historic rate of sea level rise over the past 100 years or so projected out in the future. So if there were no change in conditions that would affect sea level rise, and we just projected historic rates into the future, this is what we would look at. But it's pretty well recognized that sea level will rise, principally associated with a warming climate, warming oceans, and changes in barometric pressure as a result of a variety of atmospheric things that are going on, and that the sea level rise rates will increase. Here are two, and I brought these out because they represent some rates of sea level rise that we're going to use. We're going to describe the effects of which on our marshes in a moment. Just take one point on that, on this graph, on this orange line. Connecticut, state of Connecticut has adopted an upper bound of planning for sea level rise by mid-century, the 2050s, of 20 inches or about 50 centimeters by 2050. So given that standard, we picked this line, which included that data point. And if you were to project it, it's about on this axis, on this side in inches, millimeters on this side, inches on this side. By the end of the century, we would have about 50 inches of sea level rise. Under the highest scenario that was used, we would have about 72 inches or 6 feet of sea level rise. Now, what's interesting is these rates were taken from a New York Academy of Sciences study done for New York Harbor by the state of New York in 2016 that's based on 2010 data. Most recently, the National Oceanic and Atmospheric Administration has come out with new regionally adjusted sea level rise rates for projected into the future for coastlines across the US, including 2 points in Connecticut for New London and Groton. If we choose the New London tide gauge to determine what NOAA is predicting for future sea level rise, it's predicting 27 inches by mid-century and 76 inches by 2100 using a middle high type of scenario. So NOAA used 6 different projections. If we choose one that's slightly above the midpoint, a medium high kind of projection like we did here, we see that these rates of sea level rise that are currently predicted under this medium high scenario significantly exceed the 20 inches and 50 inches that were used in the generation results from the SLAM law, which I'm going to show you now. Okay, so here's the East River Marsh and responses to 2 different sea level rise scenarios by 2100. Here's the existing marsh. I'm going to walk you through the legend here. The orange is the high marsh, and you can see that much of the East River Marsh is dominated by this high marsh that's infrequently flooded, occupied by about 3 or 4 different types of grasses and a couple of other plants that we know have significant benefits to wildlife and water quality and carbon sequestration. Just a little bit of context: Clabbered Road crosses the East River right about here. Parts of Grass Island are a little bit lower. They do have some low marsh on it, and the other low marsh is usually just along the creeks. If you see the creeks coming through the marsh, right along the edges of those creeks where that low marsh is, that Spartina alterniflora or saltwater cordgrass. If we go now and apply the 50 inches or high medium sea level rise to the East River Marsh, we see a dramatic change from it being a high marsh dominated system to a low marsh dominated system, a much different plant community that will certainly have ecological implications, some of which though we still don't understand. If we look at a high sea level rise scenario of 72 inches, which coincidentally is about the medium high projection under the more current NOAA projection for Connecticut shoreline, we see a dramatic change in the shoreline, in the marshscape of the East River Marsh, it becoming dominated by tidal mudflats and low marsh along the edges. And this is going to have significant implications for some species that use the high marsh, such as the salt marsh sparrow, which nests there. And if it cannot, if it's flooding more frequently at higher elevations, that particular species is likely not to do very well. Just an example of one possible change. So, what does this marsh look, what does it look like on the ground? Just kind of some visual examples. So here's a high marsh dominated system. Right along the edges of the creeks in this are these low marsh. There's low marsh with these tall grasses, but this is kind of a typical scene of a high marsh. A low marsh dominated system, which exists throughout the north shore of Long Island, on the island of Long Island, North Shore. They have mostly low marshes, as does our neighbors to the east in Rhode Island. Many of their marshes are low marsh. For some reason, I don't know the reason, for some reason, we have what we call a little bit more elevation capital, just kind of a fancy word of saying our marsh platform or surface elevation sits a little bit higher in elevation than the marshes on the North Shore of Long Island or in Rhode Island, where they have these low marsh systems, not the same kind of a diversity of plants that you would find in a high marsh system. And then eventually by 2100, if these models are correct, worst case scenario would be this type of situation where we have the marsh disappearing, the marsh grasses disappearing, being replaced by mudflats and open water. So now let's take a look at this high medium sea level rise scenario, which is kind of the mid-level scenario now under more current projections of sea level rise, what it looks like in 2055 and 2100 under this medium high sea level rise scenario. So by 2100, we don't have the mudflats and all the open water. We still have lots of marsh, but it's changed from a high marsh dominated system with a little bit more diversity to a low marsh dominated system. And we also see some new marsh popping up in some areas, such as these areas. And this is where I really want to focus the attention now is, some of the low hanging fruit here is just let Mother Nature do her thing and allow some of these upland areas adjacent to the marsh to flood regularly to create new marsh as a way to replace marsh that we may be losing in the future. So for the East River, we've identified about 12 of these larger marsh migration areas. We used kind of as a filter, we wanted to find only those marsh migration areas that were greater than 10 acres and had a high probability of becoming new marsh. I won't describe to you how we determine this high probability. It was done using a statistical analysis of the model, which was run several hundred times under different sea level rise scenarios to produce areas that were more likely than others to support marsh migration areas. And here we have about a dozen of them. Here's that one that I just showed you along the Amtrak rail line. So what does this look like, this marsh migration? So with increasing water levels coming up over the marsh, flooding the uplands, we start to see marsh dieback in a variety of ways. We see coastal forests starting to disappear in some of our areas, and this formerly dry upland area now being invaded by this common reed or some other types of other plants that do well with relatively infrequent flooding of marshes. But then as this continues, as these areas become more frequently flooded, we see this kind of iconic high marsh type of vegetation starting to move into the forest, the forest being further killed off. We start to see marsh grasses growing in here, as well as some of the shrubby plants associated with the marsh border in the transitional areas. And as this continues, it would change from this kind of forest that's disappearing, turning into shrubland, into this high marsh type of environment. So now, here's what we did. For those 12 marsh migration areas, we're starting to look at them at the parcel scale and trying to identify where they exist and what kind of land cover they have on them and what kind of potential do they have for supporting marsh in the future. Here's the Amtrak rail line. Sawpit Road is kind of over here. Soundview Road's not far off. Here we see some parcels shown in yellow that the SLAM model indicates will become marsh in the future that are currently in private ownership, not protected. And here is a marsh migration area that we recently added to our East River Marsh wildlife management area. So this is kind of one of the first steps. We tried to apply current aerial imagery to make sure that these areas that the model said were appropriate for supporting marsh in the future actually did have the type of land cover that could support marsh in the future. And we threw out any of those that the model said were going to be marsh migration areas, but because of current land cover type that was missed by the model, these marsh migration areas probably don't have very good likelihood. So we then took the next step. So here again are those areas. And we started collecting imagery to try to figure out what they look like. So here, for example, are 3 marsh migration area parcels. Here's what they look like from the road. We didn't go onto these properties because they're privately owned, but just pictures we can get from the road. We need to learn more about them as to whether they have a good potential for migrating, for the marsh to migrate in the future, much like this one did. This was a real winner. When we saw this, we knew it was very well suited to marsh migration. This is what it looks like. So if you're looking kind of to the west here now, the camera, when I took this photo, I was looking this way. This little upland island here is this little upland island here. And here's that low, flat, dry uplands that is already converting to marsh. The last time I was out there about a month ago. So next steps, what do? We need to further verify which of these 12 marsh migration areas are going to have the greatest potential to support marsh migration in the future at that parcel scale. We need to understand you guys who own this property. We need to understand what your concerns are as marshfront property owners. And we want to know if you'd be interested in working with us to enter in agreements, perhaps to restrict future uses of the marshfront of your property to ensure that even after you no longer own it, that there is a restriction on the property through a conservation easement that will ensure it remains undeveloped and able to accommodate the upland migration of the marsh with sea level rise. For those who are unfamiliar with conservation easements, they're voluntary agreements between a landowner and some kind of conservation organization, whether it be someone like DEP or land trust, to permanently restrict or limit the use of the land to protect their conservation values. Wherein the landowners don't lose all of the rights of ownership. They retain many of them, including, for example, the exclusive right to occupy the property, to sell it, to pass it on to their heirs, to make certain improvements to the property. And it's kind of thought of as a bundle of land ownership rights, with one of the rights to build homes, for example. You can extinguish that right, sell it to a conservation organization, and then pass on the rest of your retained ownership rights to others to sell the property, but not with the right to further develop the property for the area that's subject to the conservation restriction. So that's where we come to wanting to know more about your interest in this. And what other questions or concerns do you have about this concept of conservation easements and restrictions? If you're on the call and you own property adjacent to a marsh, perhaps you own part of the marsh, perhaps you own the upland. If I were to come to you and say, would you be interested in restricting uses of your property along the marsh that are an upland area that could be marsh in the future? What would your reaction be? What would be some of your concerns? What would be some of your questions? Is there anyone who's willing to share maybe some of their concerns or questions, or maybe just misunderstandings of what a conservation easement is?
David, someone on the call named Walter had a question. So Walter, if you wanted to ask that question now or respond to David's question. Oh, you're muted. Sorry. And David, we do have some folks writing into the chat as well.
Okay.
Walter looks to unmute himself.
Okay.
There we go. Walter, go ahead.
Yeah, so my question, I think David is on a new topic, which is really what would landowners like to do. I was really talking more about, which trying to get in before we were talking about places that were, we've seen change. As
Yeah, like
when I look at a lot of Spence Creek, which floods quite a bit, and it's quite it's complex to us who don't follow this closely. Who really has jurisdiction over the wetlands? Is it the tidal wetlands? Is it, or is it the town? All of that is something maybe not for this discussion. You can bring that up later.
No, I think it's a very relevant question. Yes, the state of Connecticut has a coastal permitting program called the Tidal Wetlands Permitting Program. And its jurisdiction is over tidal wetlands rather than inland or non-tidal wetlands. So if you were to propose an activity that is in a wetland that's subject to the ebb and flood of the tide, and we determine that it's a tidal wetland based upon it being subject to tidal inundation and containing some plants that indicate it's a tidal wetland, then the state of Connecticut would be the permitting authority you would need to come to in order to perform that activity in the wetland. If it is a non-tidal wetland, you have your own Inland Wetlands and Watercourses Commission, and they would have the sole authority to review applications for activities in these non-tidal or inland wetlands.
So we'll just, David, one follow-up. So if the land isn't tidal or inland, it just, you're concerned about allowing migration, that's really left up to the property owner voluntarily allowing for
Yes.
migration at this
Yep.
point.
Yes,
Or,
it is.
or if there's a proposal to add, to build or to bring soil on, that will still come back to, maybe not come back to, I guess, zoning is where it lands.
Yes, you're likely you need to get a zoning approval for it. If
Yeah.
it was not an
And I
inland
think
wetland, not a tidal wetland, but was in one of these marsh migration areas that we're projecting could be wetlands in the future, but currently are dry and don't have the plants that support tidal wetlands currently, you would go to your zoning commission for approvals.
Yeah, and I guess the question for us as who live in the different towns is how to get our zoning commissions to think more about sea level rise. And it's partly education and partly, I guess, not changing regulation, but more education.
Yeah, no, it could be about changing regulations as well. Some towns are called non-infringement areas that are within 100 feet of a tidal wetland. I know, for example, for the town of Stonington at one point, I don't know if they still have it, but they did not allow any activity, any earth disturbance within 100 feet of a tidal wetland. And that's a great way to protect tidal marsh migration areas. But other communities don't have that. And there's all kinds of flavors in between. So it really depends upon your community. And I think it would be a great idea if you encourage your zoning commission to examine how it regulates these areas that are within a certain distance of a tidal marsh.
Thank you.
Good question. Any other questions about what a conservation easement is, what it does, what you're left with, how it works?
Dave, there is a question in the chat that says, are there any tax credits or write-offs that are in place or could be considered in the conservation easement program, kind of like property tax rejections? That was by Sharon B.
Yes, and you should consult with your tax professional to get an answer on that, because it really depends upon on your unique income tax situation. But yes, there are tax benefits if you were to donate, for example, a conservation easement or sell it to a conservation organization at a value less than it's appraised at. So what we would do if we were working with a landowner and this became a matter, we would ask the landowner, or we would get an appraisal of the property, what it's worth currently and what it's worth with the conservation restriction on it. Let's say you have a 2 acre, or let's say you have a 10 acre property, 2 acres are marsh migration area. And we were interested in placing a conservation easement on those 2 acres. And let's say you were allowed to build something on those 2 acres, maybe not another house, but perhaps a pool, a shed, some other type of structure. If the conservation easement then restricted or prohibited the those construction activities on those 2 acres, then the appraiser would determine what the value of the property is without your ability to construct on those 2 acres. And the difference between those two appraisals would be the value of the conservation easement. And if you were to sell that conservation easement for less than the value that appraiser assigns to it, then you could potentially use that difference for tax benefits. But again, exactly what the tax benefit is depends upon your tax situation. You would have to work with your accountant or tax lawyer to determine the extent of that benefit. Any other questions about easements?
There was one question in the chat from Anne who said, we live on the eastern edge, Neck River. How can we find out if portions of our 2+ acres would be appropriate for an easement?
That is a good question. We would have to come out and look at the property. But right now, we are focusing on the East River. We do have funding to help acquire conservation easements, but currently we're looking at the East River. But if you had questions such as that, someone from my agency could come out and help you generally define the area of tidal marsh on your property. And I actually have a program results from the SLAM analysis where I could actually look to see what the computer generated projection is for marsh migration on your property. So we do have data sources available to do that. But right now we're reserving our funds to help conserve the marshes along the East River Marsh. There are no others. I'm going to continue on, but there will be an opportunity one more time for questions. So what we're trying to do to kind of sum things up here is making sure that if there are areas of tidal marsh that are adjacent to undeveloped uplands that are suitable and capable of moving outside the existing boundary of the marsh to dry uplands, that we want to make sure that those areas will remain available for that upland migration of the marsh. And what we need to do next is to try to better identify where those best opportunities are. We plan on going out and doing more field visits and trying to collect more imagery to kind of triage those properties that we think have the greatest value. And we want to contact those landowners as to, if you have one of those properties, would you be interested in talking with us about the future management of your property to accommodate marsh migration? And more generally, do you have other technical assistance questions about concerns about more frequent flooding of your property? And are there less destructive ways to try to, for example, manage coastal erosion without putting hard structures like the riprap rock that was shown in an earlier photograph? There are ways to try to minimize coastal erosion without modifying the landscape such that the marsh would be able to migrate in the future if it was done in the right way. So that's kind of our next steps. We have a variety of information to give you that will further describe. For example, we have a great East River Marsh video. Maybe some of you have seen it. We have an East River Marsh fact sheet. We also have a little mini report, about 6 or 8 pages, that goes into a little more detail about why the East River Marsh is important, what some of the challenges are, and how we might respond to some of those challenges. What are some of the marsh restoration projects we're thinking about in the marsh? There is a model you can go to called the Sea Level Affecting Marshes Model. It's on this website at the Connecticut Environmental Conditions Online website at UConn. But that model only shows you the results of marsh change for 21 of the largest marshes in Connecticut. That is, those marshes over about 95 to 100 acres. So the smaller marshes in Connecticut would not be displayed here, but I do have a computer program that shows results for all marshes. So if you're particularly interested in your property on a marsh that's not included within the results reported here for these 21 largest marshes, we can get that to you. Connecticut Sea Grant has done a nice job putting together a coastal planting guide of how you might want to manage your marsh front using plantings to control erosion. They also have an experiment going on underway in the town of Stonington, where they're preparing a test plot that's a marsh migration area, and they've changed the vegetation to kind of jumpstart the marsh migration process. There's a blog and a website that describes that project. And then also the University of Connecticut also did a survey of marshfront property owners, and it asked them the kind of questions I'm asking you and what your response would be. It's kind of an academic paper, a little bit dense, but if you're willing to wade through it as a marshfront landowner, some of the things might resonate with you, because they went into great detail as to asking folks what some of their concerns are about moving forward with plans or restrictions on your property, and who you'd want to talk to if you were considering perhaps donating or selling a conservation easement. So there's all kinds of resources out there. You'll be able to use this recording, or we can provide, we have your email address if you signed up for this. You can email us and ask. We can send you basically this list of resources if you wanted to look at it on a single page. So Any other questions that we haven't gone over? I've kept you quite a bit, and I appreciate your kind attention. We have some contact information from me here and from my colleague Luke at Audubon, Connecticut. If you have questions for us that you don't want to raise here, you want to talk one-on-one, we'd be willing to do that. I have some additional questions for you to wrap up the evening, but at this point, is there anything else that on your mind that we didn't discuss, or perhaps I wasn't clear enough in explaining?
David, the only thing that I would like to add is that Menunkatuck Audubon Society is doing the marsh migration studies, which are line transect studies, which right now are being done at the Salt Meadow, Guilford Salt Meadow Sanctuary. And the purpose of these studies is to ground truth what is shown in the SLAM model projections. And this is a project that is has 2 days, one in the spring and one in the fall, when we're out there analyzing the plants and the animals and so forth. And this is an ongoing project for the next 80 years, we hope.
Thank you. Some last parting questions, just to kind of jog your memory of things you might want to ask if you haven't already. I'd kind of like to know, you marshfront property owners are right on the front line of flooding and coastal erosion. And I'm curious, if you haven't already discussed them, what are some of your concerns about living on a marsh? Are you seeing any marsh erosion? Are you seeing more frequent flooding of your uplands? Do you notice any changes in the types of plants that are growing perhaps in your backyard with more frequent flooding of salt water? And if you have questions, what are those types of technical assistance do you need from us? We do have folks in our office who are experts in tidal marsh, and we do know folks who have experimented with different types of coastal erosion techniques that are more beneficial for the marsh than hard structures. Anything else you guys want to talk about before we call it a night?
David, I'd just like to add that Sharon put the links in the chat, and if anybody wants to save the chat, open it. In the lower right corner of the chat are 3 dots. Click on those 3 dots and you can save the chat. It goes into a text file in a folder called Zoom.
Oh, yeah.
And if for some reason that doesn't work out, you have my email address, david.kozak@ct.gov, and Luke's address. Send us an email and we'll send you a copy of that page. Well, with that, you've been a very fine, engaged audience. I've enjoyed virtually meeting you, and perhaps